Hello, I'm Seema and welcome to part 19 of the chapter States of Matter. In this video, we are going to solve a few numericals based on the topic Dalton's law of partial pressures and the partial pressures in terms of mole fractions. So let us start with the first numerical. The numerical reads that a neon oxygen mixture contains 70.6 grams of oxygen and 167.5 grams of neon. If pressure of the mixture of gases in the cylinder is 25 bar, what is the partial pressure of oxygen and neon in the mixture? So now we are talking of partial pressure of the two gases, and he has given us the masses of the gases, so we can calculate the mole fraction. And what is the relationship? The relationship is, what are we looking for? We are looking for the partial pressure of any gas is equal to the mole fraction of the gas and the total pressure, P total, right? Partial pressure is equal to mole fraction, which is given by X, and into P total. And P total is given to us as 25 bar. And we have to calculate the mole fraction of the two gases. And from this, we would be able to find out the partial pressures of both the gases. In order to arrive at the mole fraction, we must first know the number of moles of each gas. So our first step would be to find out the number of moles of both the gases. So let us start with finding out the number of moles of oxygen. Number of moles of oxygen. Well, how do you find out the number of moles? The mass given divided by the molar mass. The mass given should be in grams, divided by the molar mass in grams will give you the number of moles. So what is the mass of oxygen given to us? Contains 70.6 grams of oxygen. So we write 70.6 grams of oxygen divided by the molar mass of oxygen is 32 grams. We already know that. Okay, so if you divide this by 32, you get the number of moles of oxygen, which would be equal to 2.21 mole. Right? Let us now calculate the number of moles of neon. What is the molar mass of neon? Number of moles of neon. The molar mass of neon is 20. And what is the mass that is given to us? 167.5 grams. So 167.5 grams of neon divided by its molar mass, which is 20 grams, will give you the number of moles, which would be equal to 8.375. 8.375 mole, right? Now that we have calculated the number of moles, our next step would be to find out the mole fraction. How do you do that? What is mole fraction? If this is the whole of the mixture, then out of this, that whole means it is 1. Out of this, what fraction is one of the gases? So mole fraction would be number of moles of one gas divided by the total number of moles. And it is represented by X. So mole fraction is number of moles of a gas divided by the total number of moles of the mixture, right? That will give you the mole fraction. So it is represented by X. So X, mole fraction of oxygen, what would it be equal to? It would be, what is the number of moles of oxygen? It is 2.21, and divided by the sum of the moles, total number of moles is 2.21 plus, how much is this? 8.375, right? Now what is the mole fraction then? The mole fraction of oxygen when you calculate would come out to be 0.21. Since it's a fraction, it does not have units. The units would cancel out. Similarly, if you calculate the mole fraction of neon, you would get what is it is 8.375 is the number of moles of neon divided by 2.21 plus 8.375, and when you calculate this, it would come out to be equal to 0.79. So now you have calculated the mole fractions of both the gases. There's another way how you could have calculated the mole fraction. Once you calculated the mole fraction of oxygen, the mixture consists of only two gases. So one whole makes, out of one whole, 0.21 is oxygen. So what would the rest be? The rest would be neon. So what is that rest? 1 minus 0.21, if you do it, that would also come to 0.79. So you could find out the mole fraction of neon by this. Whenever you're finding out mole fraction of a mixture of substances, the last one that is left, you can always subtract it from the total of 1. The sum of all the others and subtract it from 1, you will get that amount. Anyway, moving on now. What are we looking for? We are looking for the partial pressure of both the gases. So let us now calculate the partial pressures of the gases. Partial pressure of oxygen would be equal to the mole fraction of oxygen into P total, right? Now what is the mole fraction of oxygen that we have calculated? We've calculated 0.21, right? Into what's the total pressure given to us is 25 bars. So 25 bar, if you multiply it by this, you will get the mole fraction of oxygen would be 5.25 bar, right? And what would the the partial pressure of oxygen would be? 5.25 bar. And what would the partial pressure of neon be now? It would be equal to the mole fraction of neon into pressure total. So this would be equal to, what is the mole fraction of neon that we've calculated? It is 0.79 and P total is 25 bar. You'll get the partial pressure in bars, and when you calculate this, you get 19.75 bar. Right? So this is how you arrive at your answer. Okay. Now this is question 5.7 of your NCERT textbook exercise. Let us see what it says. What will be the pressure exerted by a mixture of 3.2 grams of methane and 4.4 grams of carbon dioxide contained in a 9 decimeter cube flask at 27 degrees Celsius? Let us see what all is given to us and what is it that we are looking for. We have been given what will be the pressure exerted by a mixture. It means we are looking for total pressure. In order to know the total pressure of a mixture of gases, you should know the individual pressures or the partial pressures of both the gases. In order to get the partial pressures, we will apply the ideal gas equation here. And the ideal gas equation is PV is equal to nRT. But we've not been given the number of moles, we've been given the masses of both the gases. So in order to calculate the number of moles, that is N, we should know the mass, that is which is given to us, and the molar masses of the two gases, and then we'll be able to solve. So what is the equation that we are going to use? We are going to use PV is equal to nRT, and the nRT PV, we are looking for partial pressure. So P would be equal to, what is N? N is the mass given upon capital M, which is molar mass, RT into V. So this is the relation which we will use to find out the partial pressures of the two gases. Now let us see what are the quantities that are given to us. What are the two gases we have? We have methane and we have carbon dioxide. Okay, so let us start with methane. What is the mass of methane? The mass of methane given to us is 3.2 grams, right? And what is the mass of small m of carbon dioxide given to us? The mass of carbon dioxide given to us is 4.4 grams. Now, in order to calculate the number of moles, we should know the molar mass. So, in the very first step, let us first calculate the molar mass of these two gases. Molar mass of methane, carbon has the mass of 12, hydrogen has a mass of 1. There are 4 hydrogens, so 12 plus 4 makes it 16. So we have 16 grams per mole is the molar mass of methane. So what is the molar mass of carbon dioxide? The molar mass of carbon dioxide is carbon, the mass is 12, oxygen has a mass of 16, 16 into 2 is 32, 32 plus 12 will make it 44. So we'll get 44 grams per mole. Right? Now what else are we given in the question? that you have 3.2 grams, 4.4 grams of carbon dioxide, which is contained in a 9 decimeter cube flask. The volume is the same, so we'll not write volume methane, volume carbon dioxide. V is just V, and volume is 9 decimeter cube. But in order to use it for our for the Rydberg, the gas constant, I would like to turn it into meter cube. So it would be equal to 9 into 10 to the power minus 3 meter cube. Right? And what else is? Temperature is given to us, which is 27 degrees Celsius. And you are aware that temperature, whenever it is in degrees Celsius, we have to convert it to the Kelvin scale, because the degree Celsius cannot be used for gas laws. So convert it to Kelvin, add 273 to it. So this would be equal to 300 Kelvin, right? Now what would the value of R be? R depends, the value of R that you choose depends on the units that you are using. The units of what? Pressure and volume. Mole and Kelvin remain the same. So pressure and volume, it would be 8.314. Yes, 8.314. What is volume here? Meter cube. Pressure we calculate in Pascal, and per Kelvin per mole, right? After having done this, let us now calculate the partial pressures of both the gases. After we get the partial pressures of both the gases, we can find the sum of the pressures, which will give us the total pressure. So let us begin with methane. What is the partial pressure of methane? Partial pressure of methane would be equal to M of methane. Now we are using this. M of methane divided by capital M of methane into R into T, and this will be into V. Substitute the values. MCH4 is 3.2 grams. This is divided by 16 grams per mole. What is the value of R? 8.314, and what are the units? Meter cube, Pascal, per Kelvin, per mole, right? And into, what's the temperature? Temperature is 300 Kelvin. So this is our numerator, and for the denominator we have into V. And what is V? 9 into 10 to the power minus 3 meter cube, right? Now that we have substituted or plugged in all the values, let us cancel out the units. When we cancel out the units, we should get the unit Pascal in our result, and that will tell us that we have plugged in all the values at the right places. So let us start cancelling. Gram, gram get cancelled. Per mole get cancelled. Meter cube get cancelled. Kelvin inverse and Kelvin get cancelled. We are left with Pascal, and that is what we are looking for, right? So it means we plugged in the right values, and now if you find out if you calculate this, you will arrive at the answer 5.543. 5.543 into 10 to the power 4 pascals will be your pressure, partial pressure of methane, right? Now, similarly, let us find out the partial pressure of carbon dioxide. If you find out the partial pressure of carbon dioxide, plug in the same values now for carbon dioxide. MCO2 into R into T upon MCO2 into V. Put in the values. What is MCO2? Is 4.4 grams into R is 8.314 meter cube, Pascal, Kelvin inverse, mole inverse into 300 Kelvin divided by 44 grams per mole into, the volume is 9 into 10 to the power minus 3 meter cube. Now, since I've already cancelled out the units, I know I've plugged in the right values. So let us just go to the numerical part of it and find out the what value we get. So pressure of carbon dioxide would, when you calculate it, would come out to be equal to 2.771 into 10 to the power 4 pascals. Now what is P total? P total would be equal to the sum of the partial pressures. So it would be sum of P methane plus P CO2. Put in the values. This will come out to be 5.543 into 10 to the power 4 plus, what is this, 2.771 into 10 to the power 4. So 10 to the power 4 remains as such, and when you solve this, you'll get 8.314 pascals. Both of these are in pascals, so you get Pascal as your answer. So this is the total pressure. What was the question? What will be the pressure exerted by a mixture of 3.2 grams of methane and 4.4 grams of carbon dioxide contained in a 9 decimeter cube flask at 27 degrees Celsius? So we have found out the total pressure using the ideal gas equation and the Dalton's law of partial pressures. So now this is going to be the last question that I will solve for this topic. This is question 19 of your NCERT textbook exercise. The question reads that a mixture of hydrogen, dihydrogen and dioxygen at 1 bar pressure contains 20% by weight of hydrogen. Calculate the partial pressure of hydrogen. You have a mixture of two gases and the total pressure is 1 bar that is given to us, and the percentage of one of those is given. Obviously, if the percentage is given, if you have 20% of hydrogen, oxygen would be 80%. Let us convert the percentages into grams. Let us assume that we had 100 grams of the mixture of gases. So out of that 100 gram, 20% is hydrogen, which means let us assume solution. Let us assume that the mixture of gases weighs 100 grams. Then what will be the mass of hydrogen? The mass of hydrogen, MH2, would be equal to 20 grams. And what would be the mass of oxygen? Mass of oxygen then would be 80 grams, right? Now what is, in order to calculate the molar in order to calculate the mole fraction, we should know the molar masses. Now hydrogen has a molar mass of 2, H2 has a molar mass, MH2 is equal to 2 grams per mole. And what is the molar mass of oxygen? Molar mass of oxygen is 32 grams per mole, right? So let us now first find out the number of moles of each gas in this mixture. If we had a mixture of 100 grams of the gases, then out of which 20 grams was hydrogen and 80 grams was oxygen, then we would calculate the moles, number of moles of both, so that we can calculate the mole fraction. Now why are we looking for the mole fraction in the first place? We are going to use the relationship of, you have to calculate the partial pressure. Partial pressure is equal to the mole fraction of the gas into P total. And P total is given to us, so we'll calculate the mole fraction now. So from this, what is the number of moles of hydrogen? Number of moles is equal to mass upon molar mass. So number of moles of, let us say, hydrogen would be equal to 20 upon 2, which is equal to 10 moles, right? And what is the number of moles of oxygen? It would be equal to 80 grams upon 32 grams per mole. So grams and grams per mole. You should always write down the units. So when you do this, you come to know how much is this? This would come out to be 2.5 moles. 2.5 moles is the mole fraction of oxygen. Now you have the mole fractions of both the gases, and you have to find out the partial pressure of only hydrogen. So what is partial pressure of hydrogen? Partial pressure of hydrogen would be mole fraction of hydrogen into P total. Let us calculate the mole fraction of hydrogen from this. Mole fraction of hydrogen would be number of moles of hydrogen is 10 moles. And since it's a fraction, actually it will have no unit, so we could cancel out the unit here already, divided by the sum of the two number of moles. So it will be 10 plus 2.5 into, what is P total given to us? P total is 1 bar, right? From this, when you calculate the partial pressure of hydrogen, it will come to be 0.8 bar. So that was a simple question. So with this, we come to an end of this subtopic, that is Dalton's law of partial pressures and partial pressures in terms of mole fraction. In the next video, we'll move on to the kinetic molecular theory of gases. If you found the video helpful, please give it a thumbs up. I'd appreciate that. Subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.